friends. In this video, I would like to do a project with you where we will estimate the value of pi. In order to do this, we will run a simulation based on this drawing that I have on the screen. So in this drawing, I have a circle inscribed inside of a square, and you can pretend that the square is a dartboard. So let me ask you, if you were to throw a dart at this dartboard, what do you think is the probability that the dart will hit the circle? I think that this probability is the area of the circle divided by the area of the square. Okay, so if you think that the area of the circle is something like 80% of the area of the square, then 80% is a chance that the dart thrown at the board will land inside the circle. So we also know that the area of a circle can be represented by pi r squared. So here, the radius of our circle is just 0.5, and the area of the square is just side times side. So if you solve for pi, you see that pi is equals to 4 times n. So you see, you can estimate pi as 4 times n. So again, what is n? N is the probability that a dart thrown at the board will land inside the circle. Okay, so we have to do a computer simulation to figure out what is n. So the simulation entails that we throw many darts at the board. For example, let's say we throw 1,000 darts at the board and 800 of those darts land inside the circle. Then we can say that n is 800 divided by 1,000, or 0.8. To begin our code, let's just throw one dart at the board and see if it will hit the circle. So if you throw a dart at the board, wherever the dart lands, its position will have an x coordinate and a y coordinate, where both the x and y coordinates will be some random value between 0 and 1. So let's assign that random value to our x and y coordinate. Okay, so for x, we have used a function called uniform that exists inside of a library called random. So what this formula, or rather what this function does, is it will pick a number between the lower limit here and the upper limit here. So in this case, it will pick a number randomly between 0 and 1. And uniform means that any number between 0 and 1 has an equal chance of being selected. So you see, in order to use this uniform function, I must import the random library. Okay, so now it works. Okay, so once we have the position of the dart, how do we know that the dart is inside the circle or not? Well, all we have to do is find the distance formula between the dart's position and the center of the circle. And if this distance is less than 0.5, then the dart must be inside the circle. So what is this distance formula? Here it is. X and y represents the position of the dart, and 0.5 and 0.5 represents the coordinate of the center of the circle. So in order to program this distance formula, we have to use a square root, which is inside of the math library. So I will import that now. Okay, so now I can find the distance. Okay, so you see I am using the function called square root, which is inside the math library. So now I can type in this equation. Okay, so you see in Python, if you want to do an exponent, you have to do the double star. Okay, that is exponent. So did the dart hit the circle? Well, I don't know yet, so I would say no. So I will test this distance, and if it is less than 0.5, then I will change hit to 1, meaning yes, it did hit. Okay, so now I will print hit to the screen and see if the dart hits the circle. Okay, so I ran the simulation once. So every time I run the simulation, it throws one dart at the board. So the first dart hit the board. I can run it again, and the second dart also hits. And the third dart also hits. Okay, so I don't want to run this program 100 times or 1,000 times. I want to run it only once and get it to simulate 1,000 throws. So how do I do that? That means that the way to do it is I have to nest all of this code inside of a for loop. Because with a for loop, you can loop it as many times as you want. So to get this code ready to be looped or inside a for loop, I will indent all the lines of code. Okay, so for this for loop, you see that I put 0, 100, which means that count will start at 0 and stop at 99. So between 0 and 99, that's 100 loops. Okay, so you see here I have hit equals 0 because I am initializing the number of hits. So I want to remove that from the for loop. The reason why you want to initialize outside the for loop is that if you initialize inside your for loop, then that means it is initializing to 0 for every loop. It always goes back to 0. So we don't want that because we're going to want the number of hits to accumulate. So hit will no longer be 1. It will be hit plus 1. That means that every time it hits, the number of hits will be updated to be the existing number of hits plus 1. Okay, so what is n? N is the number of hits divided by number of times you've thrown the dart. So it will be hit divided by 100, because 100 loops means we throw 100 darts. So let's run this now. Okay, so it looks pretty reasonable, because remember, pi is 4 times n. So if you want pi, you just put 4 times this fraction. Okay, so pi is estimated to be 3.28. But we can do it a little bit better. What if we put 1,000 times? Okay, that's a little bit better. And you see this 1,000, you don't have to hard code it. You can use a variable to represent this. So for example, you can do number of simulations equals to 1,000. That way you don't have to hard code this number 1,000. Because if you ever want to change the 1,000, then you would have to change every instance that you wrote the number 1,000. But now you don't. You only have to change it here. Okay, so 3.172. What if I run 10,000 loops? Okay, so it gets a little bit more accurate the more loops that you have. Okay, that's it for this video. If you found this video to be of value to you, then please like, comment, and subscribe, and I'll see you in the next video. Thank you.